Hello, this is Jeremy playing Oxygen Not Included. In this episode, I'm going to start to convert the hot magma that's in the bottom of this space and turn that into energy. So in order to do that, I have to dig out a spot that has access to the hot magma. I'm going to need to have at least 10 tiles, assuming that I want two steam turbines to run. That's what I'm going to have. The goal is of having two steam turbines. So going through this spot that caused a carbon dioxide explosion of gas all in the past. But anyway, that has been resolved. And what I'm doing now, you can see I've got a pump that is down here. I've got a water chamber that I have my dupes walk through when they go in here. And the idea is I've created a vacuum. And I want to maintain this vacuum as I'm going forward. So just in case some other gases leak, looks like I've got a little bit of chlorine that's going to come out. So I've got a pump that's going to pump that chlorine and create a new vacuum. And you'll see why that's going to be needed once I make that steam turbine area. Here is the inverted world. Over here, I am in the process of freezing water, turning into ice. And that is where sleet wheat's going to grow. Two dupes over here, meaning this, so that I'll have a spot to grow free sleet wheat in the future. Looking over at the inverted world, I'm still not happy with the speed of which ice, or water rather, is turning to ice. It's quite slow. So I added in the last episode some radiant pipes. That'll help. But part of the problem is that the liquid that I'm pumping through there can't get extremely cold. Because I believe it's a salt water, or brine actually, that I pumped through there. So I can get it down to close to minus 20. And that's eventually going to freeze that water. But if I had another material that could get even colder, such as ethanol, that would speed up that process altogether. So what I'm actually going to do is produce ethanol in this world. I'm going to have it shipped over to the inverted world. I'm going to drain the brine that is in that line that's doing the cooling. I'm going to replace it with ethanol. And then I can get that down to some really cold temperatures, maybe minus 50. And that's going to do a much more effective job at turning water into ice so that I can grow free sleet wheat in the future. All right, I'm going to get a lot of carbon dioxide. I'm expecting for that, so get some mesh tiles for that carbon dioxide to flow underneath this. Carbon skimmers are already in existence, so that's going to take care of the excessive amount of carbon dioxide that those are going to create. And now I've got two output lines. I've got a water line here, so I'm going to snap this. Send all the water into the inverted world somewheres. And then we'll change that line to be a ethanol line that will fill up the line that's going to do the cooling in this world. And just doing some maintenance over here so my dupes' time aren't wasted. But I'm going to want to dump water somewheres, so I can essentially drain all the water from the pipes in the other world that I'm going to change that pipe towards, or to be used with ethanol. So just making a little change over here. Notice that the ethanol production system here is not operating. That's because they have no output pipe. So what I'm going to do, I'm actually going to put a liquid reservoir to store excess amount of this ethanol, so that if I'm not able to dump it into the inverted world, that these machines will at least be able to operate, start to fill some liquid reservoirs, which will ultimately be have that ethanol directed towards the inverted world. I've got to wait for that water to be dumped out before that happens, because I don't want this line to have a mix of water and ethanol, because a little bit of water that's in that line, once it gets down to below zero, and certainly it won't get to anywhere minus 50 before it freezes and breaks the pipes. But I'm not going to have that happen. So what I'm going to do instead, actually, just can raise the location for the liquid reservoirs, and I'm going to start to fill this. So as soon as this line connects to one of these reservoirs, actually doesn't even have to wait for that. They can go into the pipe, but it's going to go directly into that liquid reservoir, even though I'm not directing it into the inverted world. That's the whole idea. And then once those start to get full, or at least that water is been drained out of the line, and I'm going to redirect it to go in the right location, I'll be able to enable that connection. In the last episode, I experimented with this robot. It's my first robot that's ever been deployed on an asteroid, so it's pretty cool. I found out some limitations for it. It can't dig through certain things, such as that up there. Can't even dig through granite. So it also can't build certain machines or certain buildings. It's anything that's a little more advanced. But I do have a basic oxygen producing area and a little cave that my dupes can go into with a basic door that they don't have to initially build when they first get here. So it's kind of neat. Directing my attention back to this spot that's going to have the steam turbines, and this is really has two goals to it. One, it's going to produce power from the hot magma. That won't last forever. Once the amount of heat gets taken out of that zone underneath, then I won't get power anymore. So that's one goal, is just to get a little bit of power from the system. The other goal is actually to cool the spot down in the bottom, so I can actually use it for other things, because that's going to turn into various rocks, sediment, and that. But I certainly won't be able to do that until it cools down significantly. So, excuse me, I'm going to get a bit of power, but I'm ultimately going to have a long-term strategy of having access to the spot down here. Not that I really need it anytime soon. Well, it's a good thing I don't need it anytime soon, because I'm not going to have access to it anytime soon. But some point in the future, much further down the line, I might be able to start to build some bottoms in this, or start to build some buildings rather, in the spot where hot magma exists. It's certainly not going to work at the moment. So I've got a roof to this spot over here. I'm making that out of tiles so that I can run things through it if I need to. And I've got the dupes that is going to have access to stand on top of this thing. So that's going to be put in place. I've got pumps creating a vacuum in this spot. So that vacuum isn't so much necessary for the steam turbines, but it's going to be necessary for the area underneath them, that I'm ultimately going to put some water in that will turn to steam. And that's what's going to drive the energy exchange or heat exchange between the hot magma and the steam turbines, is some water or ultimately steam in that zone. And I want to make sure it's vacuum before water goes in. In the inverted world, I want to change out this brine line, which is doing cooling, turning water to ice, also cooling off the top of some steam turbines. I want to essentially drain all of that brine, because I'm going to be putting in ethanol. And the reason for that, I mentioned earlier, is simply just so that I can actually get its temperature to be much colder, so that I can do a faster job of turning that water into ice. So I'm currently growing slate wheat in the homeworld via farming, but if I actually produce enough natural slate wheat, I won't actually have to do farming, spending resources and have dupes time being wasted on that. So just going to send over some material to enable some of this. Need some more steel actually, so I'll get about 1,000 units of that. And this is my system over here to be able to transport materials. I can actually specify exactly how much, and notice I was able to say exactly 1,000 kilograms of steel. And I can send over other materials. The other nice thing is I can send food over to that world. So my dupes there don't necessarily have to produce their own food. Dupes from this world can actually send food to them. So this is a very nice thing. But right now, I need a little bit of steel for something that I'm going to build further down the line. You'll see what that is. Back in the homeworld, I'm digging out this spot that's going to have steam turbines. I'm going to have 2 of them. I can actually now start to build the area where the steam is going to exist. Now, if you're going to do this, make sure the bissolite that you have where the steam turbines are going to exist are all cold, which is the case here. So the steel that I brought over here is going to be used to build a second aqua tuner. And the reason I want 2 now is because I have 2 types of material that I'm going to be cooling. I've got a brine line, and the right side of this that is effectively going to be cooling off the top of the steam turbines over to the far right. That's going to be brine line. The aqua tuner on the left is going to be for ethanol. So that's a new ethanol that hasn't arrived in this space, but will eventually. And this is the second aqua tuner is going to be dedicated to that. So ethanol on the left, the brine line on the right, and then that way I won't have a mixing of the two materials, and I'm not going to essentially be using ethanol for cooling the steam turbines. I'm going to just be using them for turning water to ice. I'm also going to put an aqua tuner here because these steam turbines that are going to be running are going to be taking on a lot of heat. I'm going to have liquid that's going to sit on top of them, and that's going to absorb some of that heat, but I need to keep that liquid itself cool. So I'm actually going to put a steam turbine in the steam zone. So the steam itself is going to do the job of cooling that aqua tuner. I'm going to have ceramic pipes go in and out. And I'm going to essentially just direct water to go, or perhaps brine to go around this line. But the idea is I'm going to use that cooling brine to keep the top of the steam turbines to operate. Because if I get above 100 degrees, they won't run anymore. So actually I'm just going to change this location to go down one, just that I've got the right amount of pipes that go in. Because I want that cooling liquid to go in, but I also want the ability to dump in water. That's what's going to ultimately create the steam. Once I have that, I essentially need 3 lines, one for water go in, and one input and output for the brine line that'll ultimately do cooling over here. And a little bit of power will be needed for this. And this won't run forever. Eventually that hot magma is going to cool off, in which case this whole system will be destroyed and can be repurposed as something else. But until then, I'm going to get a lot of power from this system and do the job of cooling this off. Now I actually need physical access to this hot magma because that is what the water is going to interact with to create the steam. The robot in this world isn't doing a whole lot of useful things for me, and that's because I can't dig down through granite. Actually can get down over here. So I'm going to actually change the location of this ladder and just let the robot dig into that zone and maybe start to carve out some spots that my dupes would eventually need whenever they get to this asteroid. This asteroid has a lot of metal, so once I run out of some of the natural metals that I have in my world, I'll be heading over here, and just the work that this robot is doing is going to make that process a little bit easier when I get there. I'm going to have 2 steam turbines. Make sure that you put this on abyssalite that is cold, as I mentioned before. That's why I made sure that the abyssalite was cold. And I'm going to have, if I can choose the right location here, I'm going to have 2 of them. And they're going to output water. So they're going to take the hot steam, take that water, and just dump that water back in underneath. In the past, or in some other locations, I might care about optimizing this, such as using a battery to tell it when to send water in. But since this is primarily about cooling the zone, I'm not even going to bother. I'll just let it output water as soon as it can. Just in the inverted world, I'm going to be making some changes here. So I've added that aqua tuner. And the aqua tuner on the left is for the new ethanol line. And I'm going to have essentially the logic for both of these to work the same. So material is going to go into the liquid reservoir. And then the idea there, that'll mix and I'll get an average temperature. And then I'll take the temperature out of that. And then use that to determine whether that liquid will go through an aqua tuner or bypass it. So in this case, this is going to be for ethanol, probably going to look at minus 50 degrees or so for that. On the right side, this is going to be for the brine line. And it's going to probably aim for certainly above I'm not sure if I've got brine or salt water. I'm probably going to have that be set to be about 30 degrees. So if I've got anything that's above 30 degrees, the aqua tuner will run, but I might experiment with that as I see how it has an effect on the steam turbine to the right. So this system on the right is not going to run forever because the steam turbines are operating via the assumption that hot magma is down there, but once they cool that magma, that won't continue to operate anymore. But I probably will still need the brine line or the brine cooling line because I also further down the line, maybe not necessarily anytime soon, but eventually I'm going to want to make steam turbines on the left so I can cool a hot magma there, so that I could use that for space to build stuff. But that's going to be an extremely far away time. Maybe in the home world it makes sense to get rid of the hot magma. Over here, it's not quite as important, and it's more about using it for power. Since I don't have a nuclear reactor in this world, I'm actually a little bit more reliant on the fact that I've got steam turbines running, because the only other source of power is the solar panels, and those don't operate all the time. All right, so again, as I mentioned, the same logic on both sides. That liquid shut off is what is going to either be on or off based on temperature. And the idea there is that's going to either put it through the aquatuner or not if it needs cooling. The rest of this is just making sure I've got all the pipes set up. I'm using the liquid bridge to actually direct materials so that it's forcing it to go down only in the down direction, and it can even use that as a priority. So over here, this is what eventually I'm going to have ethanol go into. I actually might use this liquid reservoir that's in existence over here to take on the initial bit of ethanol, because that's currently on the home world and I'm not getting any of it over here. But if I can start to load this in here, it'll be in existence for cooling once that automation and all the other bits of pipes and that are set up for the aquatuner that's now going to be dedicated just for ethanol. All right, just going to go down here and then direct that pipe. So the output from the other world was set up for water. So anywhere where I previously wanted water to go, I don't want that to be the case. So I'm going to make a cut there, just so that I don't have ethanol go into spots where I want water. That's eventually going to be turned to ice. And then over here in the home world, just have a look at where I've got that ethanol. So yeah, I just want to create this connection, and this is going to start the process of ethanol going to the inverted world, and that's going to do a much better job of cooling. This is what I should have used in the first case, but making that change now. You can now start to see a buildup, a little bit of ethanol that has arrived from the other world that's loading now into this second liquid reservoir. And that's the one that's going to contain it just before the temperature is taken. I also want to connect the brine line, because I don't want the steam turbines to get too hot, because as this whole system has been shut off, that hasn't been operating. So just put in that. Also put in a little bit of a ladder spot here just for them to be able to access the top of that, though I don't think that's going to be a huge priority. I can see I still need access to be able to get in there, so I can build that last little bit of pipe and actually remove some of the other material that's in there. This is the home world, and I'm going to continue on working the steam turbine system here. Now, one thing that I want to do is remove ice that those steam turbines have next to them, because I'm going to be dropping brine on it, and that brine is probably going to melt that ice, and if not, the heat from the steam turbines will eventually melt that ice. And I don't know how much ice is there, and that could produce a tidal wave that goes over that and potentially flooding the steam turbines. I don't want that to happen, so I'm going to remove that ice. That's why I've built those bins above. But I'm also going to be directing brine to go on into this zone. That's going to be the liquid that's going to take on the heat from the steam turbines. And that's going to come from a source not too far away. I'm using brine. I could use water or salt water easily. Essentially anything. I'm going to maintain that temperature to be 30 degrees, so there's no way that's going to be turning to steam. Certainly not worried about it turning to ice. Automation there. I'm going to manually watch the liquid that drops off on top of that. And the idea is I'm going to be aiming for about 50 or 75 kilograms. That's going to be enough to do a good heat exchange, but it won't flood the steam turbines, which would be a bad thing. Notice that I built a tile on the left of the steam turbines, actually going to be taking the temperature of that liquid. So I'm going to actually now remove ice, and well, this will technically remove all other materials, but the main thing is ice, or anything that's liquefiable, by the way, is something that if you warm it up a little bit, turns to liquid. Do not put it in there, because that could cause a mess. All right, so final bits of the pipe being turned on. So I might actually get some brine in this area pretty soon. I disabled that right now, but I'll enable it only once I know that all the ice is out. All right, so I've cleared out all the material for this. So there's nothing liquefiable, in particular, no ice. So that's not going to create a tidal flood of water that could cause all kinds of problems. So I have the ability now to turn this on, and I'm going to start, I should start to see some brine go above that. I'm going to have to manually watch that. So hopefully I don't forget about this and have to go back, but anyway, we'll see what happens. And in the process of, or while that is happening, there's the brine that's going in. While that happens, I'm going to put a heavy watt there, so that's going to direct power into the aquatuner. And the ones above can be just a regular tile. And that is going to allow me to maintain steam on the left and a vacuum on the right. Also have a automation there. That is going to tell the brine that goes through this when it needs to do some cooling. So as it gets too warm, it will tell it to go through the aquatuner. Otherwise, it'll go through the main or the S2 steam turbines. So this is the pipe that is going to be directing water from the steam turbines back into the system. I've got to have that running, but I also have to have a brine line. So not a lot of space in this zone to be able to put all these pipes. It should be good. We'll see how this thing runs. But essentially, one water line and one steam, or no, there's no steam line. One brine line that's going to go in and out of the aquatuner if it's in need of cooling. So maybe we'll just make this actually out of clay, even though it's going to be vacuum on the right. So this is a small area, as I mentioned, and I'm realizing that liquid shop is not going to work there if I'm going to have some output go through. So what I'm going to do is just to bring that up a little bit so that I'll be able to set up all the output flow for that. The other thing is, notice that hot abyssalite has material touching it. I built a airflow tile. And the idea is, because this is in a vacuum, if that is there, that's going to prevent that hot abyssalite from interacting with objects that are sitting above it. All right, so now I'm bringing up that shut-off valve. I'm going to put it there. And the idea is, if it's enabled, it's going to send brine into the aquatuner for cooling. So that is good. And if it doesn't, it's going to send it out of the system. And I need to have a liquid bridge to make sure that it doesn't get confused with the flow. And I'm going to join this such that the priority of liquid going through here, and that's going to be the liquid, or that's going to be the brine rather, that goes from the aquatuner rather from the shut-off valve. And I also want to drain the brine that's in this line here. So I'll build this, let that filter out. That way I'll get that line available to me. Now, typically, I always take the temperature of liquid in the pipe itself. Because the system is really small, and I'm only going to be operating it for so long, well, until the magma cools off. It still will be a while. But I'm actually going to take the temperature of the brine that's in sitting with the steam turbines. So just a little bit of different way to do that. So I'll just have that be what determines whether that shutoff is, or whether that shutoff is on or off, sending brine into the aquatuner if need be. So I've got a brine line on the right, and I'm going to use that to cool off the steam turbines. This one here, as well as the one on the right, that is sitting above some hot magma. So the idea is I'm going to get brine to go through this zone, take the heat from it, and then ultimately that heat will be taken out of by the aquatuner if it starts to get too warm in the pipe. So what I'm doing at this point is now directing the brine to go into the pipe above. That's going to go into the steam turbines area for cooling off the top of that. And it's going to send this back out. But what I wanted to do is I wanted to visit the steam turbine above as well. I actually want to do that first. So I'm going to direct it to go through this way. So it'll visit the steam turbine on the top, and then it'll go down to the other steam turbines. and do a pass over there. So just setting this direction above so that the bottom pipe there that I'm building, that is going to contain the, this will be the input to the brine, and the other one on the top, that's going to be the output, sending it to the next steam turbine area. So I have my steam turbines here. I have a radiant pipe that I'm building. This is going to contain the brine and do a very good job of exchanging the temperature or the brine that's in the pipe with the actual brine that's sitting in the real world, or in the dupe world, if you want to say. But anyway, that is effectively sitting next to the building, the steam turbine. That's going to actually do the temperature exchange, so that I can take that brine and actually send it in AquaTuner. And I'll only do that when this temperature gauge right there indicates that things are too warm. And that's pretty much the cooling for that system. And this system will continue to operate until I run out of heat from the hot magma that's underneath. I'm going to actually add a liquid reservoir. I realize that I actually don't have this. And I'm going to load the brine into it before it goes through the entire system. And then that actually, now I can destroy this, and I'll start to pump in the brine into that liquid reservoir, so that I'll have some material to actually do this whole cooling, and then I eventually will be able to turn on this steam turbine system that's producing power from this very hot magma, 1,840 degrees currently. Making a small change over here. I'm storing some water, which I forgot about quite a while ago, so I might as well integrate that to the overall system so I can drain those, and it's going to act as an extra source of water, well, short term anyway, until that thing goes out. But what I don't want to do is have it actually go into the main line. I want to send it, essentially I want to create one flow where all the water sort of converges and everything gets consumed from the other end. That's why I don't want to connect it to this closest pipe that I had available. All right, so I'm finally at the point where I've got enough brine into this line. I've got a liquid reservoir which is now almost full, so I can disable that and then just create a infinite cycle that's going to go through this line here, but it's only sometimes going to go through the AquaTuner, and that's going to be based on the temperature of the brine that's sitting next to the steam turbines. Okay, so what I'm doing here is finally have brine that is going through the system. It's going through the AquaTuner, which I don't want to happen at the moment, so I changed the setting for that temperature gauge there. But anyway, that currently is in a vacuum area, so the AquaTuner would actually burn out very easily if I had forgotten about that or let that operate for a very short period of time. But anyway, that didn't happen. And now I've got this brine line, so I've got pretty much a full liquid reservoir full. That's going to direct that brine to go continually visit those two steam turbines, and sometimes visit the AquaTuner when things get too hot. The other bit is I actually need to load water into this system in order to operate. You can see that I actually had too much, or the AquaTuner was taking on heat. I need to get some water in there to maintain the temperature for that, but that's also going to be the material that's going to interact, where water is going to interact with the magma, and that's going to heat up the steam, and that's what ultimately is going to power the steam turbines. So out of this all system, actually, why don't we put this is only going to be a temporary system, so I'm actually going to put a transformer here and just put a simple wire, and that's just going to power this shutoff. And this is going to be manual, and it's manual in the sense that I'm going to watch how much water goes into this zone and manually hit that button to turn it off when it's got the appropriate amount. So I don't want to go far. I don't want to forget about things. Once I don't have water going through that system, but once this is connected and I turn that button on, I'm going to want to stay in the area and make sure I watch this such that it doesn't get way too hot. Okay, so if that pump were to continue or to operate now, once those pipes exist, obviously, that may send some saltwater brine into that zone, which actually probably wouldn't be the end of the world because I think it would ultimately just turn to steam anyways. But I think it is a little bit better just to make sure we get clean water going into that. And I've got that shut off button there that, as I mentioned, I'm going to be keeping a close eye on so I can turn that off because I don't want to get an excessive amount of water and effective or eventually steam because that may overpressure some things. Okay, so finishing touches on this brine line. That's going to go around and around, keep things cool for that. And this is looking good. This is a big moment here. First of all, I'm just about to have a brine line enabled to go around here. But the other thing is I'm in a position of being able to load water into this. Now this overall system doesn't have a button to turn on or off. Rather, it's based on the water being present. And I actually have a little bit of water at this pump. So if I enable this pump, I will start to get water to go in. And there it is already. So that's going to be heading towards this chamber underneath the steam turbines. That shut off there is currently disabled, but I can enable that soon. And that's going to send water in. But before I do that, I want to make a save. This is one of those big moments when I'm about to turn a system on, and there's just many things that could go wrong. I believe I've got everything in order, but I thought that before in the past, and one small little detail causes a havoc in your life for this game anyways. But yeah, so now that we've got that save in there so I can go back, let's turn it on. That's going to dump some water in this zone. The moment that happens, that's going to interact with the hot magma, turn to steam. There it is. A little bit of steam, good amount of temperature, 250 or so degrees. That's quickly going to enable one steam turbine to operate, excuse me. And eventually, once I turn off the water system, I suspect the other steam steam turbine on the right is also going to reach full power. But let me just need me to turn this off, because essentially the excess amount of water is providing cooling. It's preventing that second one to operate. Hopefully, I'm a little bit worried, but let's see if this catches up now that there's less amount of water going in. Oh, there we are, halfway. If I only get 1.5, I consider it a success.